Okay, good morning. Happy March 25th. Okay, so today I know that you're shocked, but we're doing dependent events. Yesterday we did independent, today we're doing dependent. And what do you think that means? That means when the outcome of one event impacts the outcome of the other. Don't you like how pretty that is? I promise you I'm getting a stylus. I just ordered it from Amazon, so I'm all good. Okay, so we could figure out the probability of dependent events just like we can with independent events. Remember, independent events are independent of each other, which means they could happen. The chances of them happening are pretty much outside of each other. But these events, the chances of them happening are dependent on each other. So let's take a look and kind of look at some examples. And I encourage you guys to pause these as you go through them so you could see what they... Okay, here we go. Flipping two coins results in one landing on heads and one landing on tails. Well, those events are pretty independent of each other. It could land on heads. It doesn't need to land on heads and then go to tails. So that is independent. Okay. The captain of the football team is selected, and then the co-captain is selected. Okay, this is a little different because if we have, let's say, 10 kids and we select the captain, now the rest of the group has a better chance of being selected because they're smaller number. So that's dependent. Anytime you change the number of outcomes, because the captain of the football team is 10 kids and then he's gone, so then there's 9 kids. So anytime you change the possible outcomes, it is dependent. Okay, so here you go. You draw a joker from the deck and then you draw an ace. Put me on pause and guess. Okay, did you guess dependent? It is, because when you draw a joker, it's 52 cards in the deck. And then once you take the joker out, now it's 51 cards in the deck. So that is why it is dependent. Aha, but look at number 4. You draw a queen, and then you put it back. And then draw a 10. Did you notice what happened there? What is it? Boom, 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 boom. Independent. Okay, so why is it independent? Because 52 cards here, but you put it back. So then there's 52 cards in the deck here. Okay, so that is independent. A coin is flipped and a number cube is rolled. Pause. Boom, 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 boom. That is also independent. That has nothing really. The outcomes are the same. You have an equal chance here. A coin is either heads or tail. And a number cube is 6 ways still. 1 through 6. Okay? Not bad so far. Wait, there's more. Okay. So here we go. And we learned yesterday that independent probability is just the probability. Ooh, did I do that wrong? Send back. Sorry. It's just... I did do that wrong. Okay, it's just the probability of A happening times the probability of B happening. Those are the two events, right? Dependent probability is the chance of A happening and the chance of B happening after A. That seems confusing, but once we get to the problems, I have a good feeling you guys will be fine. Okay, so we're back here. So let's read problem 6. Neil goes to the pet shop and selects a treat for the dog. He chooses one and then chooses another. What is the probability that Neil selects? What is the probability that Neil selects a bone and a ball? Okay, so those are the two events, a bone and a ball. So the probability of a bone. Let's start with that. Now, how many bones are there? There are 3, so we know that's our numerator. And how many outcomes are there? 1, 2, 3, 4, 5, 6, 7. So that's 7. Aha! But now, if he selects one bone, that takes out this outcome. Okay, so he selected that bone. So now we're looking at the ball. How many balls? 2. That's great. And how many outcomes do we have now? 1, 2, 3, 4, 5, 6. 6. So notice our new denominator changes. So when we multiply this, well, I could also cross factor. I could cross this out. This becomes a 2, right? So I could cross factor that. Okay, sorry about that. And so we could say that it's 1 times 2 over 14, which is really 1 over 7. I just reduced it. You could use your calculator on that. Okay, let's try. Let's go on now. Mackenzie chooses 1 candle, and that's going to tell you right away when you see that and he didn't replace it or he didn't do anything like that, it is dependent. So you're going to be changing your denominators when it's dependent. Okay, he chooses 1 candle and then he chooses another. What is the probability that Mackenzie selects polka dot? That's our first one. So the probability of polka dot. What is the probability that selects a polka dot candle both times? Okay, so he wants to select polka dots both times. All right, so let's look at this. How many candles? 1, 2, 3, 4, 5. That's our numerator right here. How many are polka dots? Well, that's just 2. Okay, but look at what he did. He took out 1 polka dot. This is fun. He took out 1 polka dot. And that left him now with how many outcomes? Possible outcomes are 1, 2, 3, 4, and of course there's only 1 polka dot left. So now all we have to do is multiply. 2 times 1 is 2, 5 times 4 is 20. When I reduce, I get 1 over 10 as my answer. Okay? Not bad. I think you could do this. I'm so excited for you. I love probability. Okay. Your assignment for today is just to move on and finish student handout 6. Take a picture, send it to me, and then homework 6. Now, homework 6, you're going to just do 1 through 10. I think you'll be really great. Let me see if there's anything on here. I think everything's okay, right? Everything looks pretty easy to do. If you get challenged, you could come to the Zoom event today. I just changed the Zoom events for you guys to 11:30 every day, Tuesday through Friday. So if you get challenged, come to the Zoom event today or come to the Zoom event tomorrow and ask your questions there. It's at 11:30. I still want to see some work. I want to see you try it. And guys, when I say shown work, I really mean like, let me just show you an example of shown work. When I say shown work and how I want to see it is I understand that a lot of times you guys use calculators, so that's fine because we want to get used to the calculators. But for sure, I want to see you guys doing that. 3/7 times 2/6 equals 1/7. The reason why I say that is because I want to see where I could help you. So your shown work should be like that, right? Just so you know, I don't want to just see the answer. Okay? All right, have a great day today, guys. I hope I see you at Zoom. I miss you guys. Hope everything's well. Take care. Bye.